My name is Bevin Tom. I'm a master graduate in energy and environmental management from European University of Flensburg, Germany. And I had been working with EA Energy Analysis as an energy consultant. It's an honor and privilege to present my research topic in front of experts like David. And let me introduce my topic to you. It's the impact of policy decisions on the Indian electricity system in the year 2040, and it's also a model-based analysis. So for contents, I will introduce the status quo of the Indian power system. Then we look at the research question which we are trying to answer. It's a model-based analysis, so input data and assumptions are the main parameters on which the results depend on. So I will explain some of the important ones. Then we look at the results and analysis, and finally we'll conclude. So as told earlier, if you look at the status quo of the Indian power system, around 78% is powered by thermal power plants, mostly coal, and only 9% is powered by renewables. This means that the power system of India is highly carbon intensive. A study from IEA in 2015 says that around more than 1,000 million tons of carbon dioxide is being emitted from Indian power system. Now, when we look into the future, how our electricity requirement growth is going, so this is a study based on the 19th Electric Power Survey by the Central Electricity Authority. And we can see that by the year 2036-37, the increase is going to be 3 times more than what we have today. So we are looking at 3 times more demand. And if we continue to be a carbon-intensive power system, it would be detrimental for India as well as global climate goals, exactly. So India government has put forward many policies. One such is the draft National Energy Policy. It was released in 2017. I heard a new version is coming in coming months. So what this National Energy Policy envisions that India can achieve a share between 29 to 36% by the year 2040. So that is the goal which they envisions. And they also make one more point that the growth will take place autonomously. That means that the market conditions at that time would be sufficient enough that it can drive the growth without any government policies pushing it forward. So what we are studying here, so we look at different policy decisions like what if the government keeps a target that they want to achieve certain share of electricity from renewables, say 36 or 29 as per their goal. What if they don't keep a target and allow only the market to put the growth forward? And what if we tax the carbon emissions in the Indian power system? For every ton of emissions from the power sector, we put a money attached to it, a kind of an externality cost. And what if we put a cap on the emissions from the Indian power system? This is based on an IEA study which looks at the long-term Paris goal to keep the temperature rise below 2 degrees Celsius. What if we do that? So these are the things we are going to study or see in this study. So the modeling tool which I have used is the Balmoral Energy System model. It is also a partial equilibrium model. That means that only the electricity system is being modeled, not the entire economy. So it is a least cost optimization model, looking at least cost capacity and dispatch. It assumes that we have a perfect competition and a perfect market system. But in case of India, it's a non-market, only 4% of the electricity is being traded into the market. So for a non-market system like India, it can show a perfect planning, how it should be. Now let us look at the main inputs and assumptions. So as told before, India is currently demarcated into 5 grid zones. So each grid zones have their own load dispatch center. They kind of manage the whole region. So I have used these grid zones as my region in my model. So it is the basic geographical entity in which I have defined the inputs, mainly the demand profile, demand, existing capacity, the plant capacities, the fuel potential, like how much is the solar potential available, and so on. So this is an example of the electricity demand profile which I have used. It is based on the POSOCO's electricity demand pattern analysis. Actually, we can see the giraffe graph here, as told by Suno yesterday. So, yes. And different energy technologies I've used here is, in non-renewables, we have coal, gas, nuclear power plants, hydro storage, that's with the reservoirs, so they can be a source of flexibility, and hydro runoff. For renewables, we have solar, wind, onshore and offshore, biomass, and small hydropower plants. So in India, small hydropower plants which are less than 25 megawatt are considered renewables. And for storage, we have pump hydro storage, and battery power systems. So we also take into account the planned capacity additions which are coming in the future as per the government policies. So one such is the 175 gigawatt renewables by 2022. Other one is a 30 gigawatt of offshore by the year 2030. And Department of Atomic Energy has a plan of implementing 22 gigawatt of nuclear power plants by 2031, and other planned hydro capacity additions. So an example of the investment cost which I've used, this is from the IRENA renewable energy investment cost. We can see that it's very interesting. In case of wind and solar, India has the lowest investment cost. So as per this study, it's only $1,100 per kilowatt. Similarly, the things have been taken for other generation technologies like wind, biomass, hydropower, so on. And solar potential is also used in the model, so as to put a cap on maximum capacity additions we can have. So this is from the National Institute for Solar, 700 gigawatt. Now let's look at the scenarios and results. So at first, we have the stated policy scenario. So it includes all the stated policies from the government side and projections till 2040. So in this, we have put a technical constraint to the model that the model will meet 36% of its electricity generation mix from renewables. It translates into a policy statement from the government that a target that we want 36% renewable in the generation mix. Now let's see what are the implications of putting such a limit. So with a 36% RE share, what we see is that the coal share has come down to 49%. But it's not such a happy news because we saw that the electricity demand has been increasing more than 3 times what we have today. So when we look at the generation, in 2017 it was around 900 terawatt hours, and when you look at 2040, it's going to double. And when we look at the capacity additions, okay, somehow missed this capacity addition. When we look at the power system flexibility, what we see is that, as told earlier yesterday during the sessions, the minimum load capacity where, as per the CRC, is 55% for coal power plants. We can see that during the midday, where the solar is high, the coal is taking up that ramming down can be seen here. Coal is able to take up. And other source of a flexibility is the pump storage system. The model actually invests at around 55 gigawatt of pump storage system. It looks reasonable in this case where the states like Tamil Nadu are looking forward in implementing more pump storage system. It could be a source of flexibility. We can see that into action during the midday hours when the solar is high. We can see that pump storage is getting stored, and during the peak time when there is demand, pump storage is discharging those stored power. So what is the effect on the emissions, on greenhouse gas emissions? We see that from what we have in 2017, it increases to 1,800 million tons of carbon dioxide. So the power sector emission is not restricted, it's growing. So when we compare it with the 2 degrees Celsius scenario, it should reach up to 562 million tons of carbon dioxide if we need to adhere to the 2 degrees Celsius goal. So so it is still high. So emissions are around 3 times more than what it should be. As I told before, this is the RE share which the draft national energy policy is envisaging. And they told that the market alone can take it up to that level. But when we put a no RE target, when only market decides the renewable energy expansion, the RE share reaches only 21%. And that will have a serious implication on the emissions from the power system and our Paris Agreement goals. One of a policy goal, tool which we can use to combat this is introducing carbon price or carbon tax. That means for every ton of CO2 emitted from the power sector, we charge a certain value of money. The price which I have used here is a progressive price. In the year 2025, it starts with $17 per ton of CO2 and increasing to $35 per ton CO2 by the year 2040. This is the predicted carbon tax values which will be coming in China, which is a similar power system. Let's look at the results. With the carbon tax, we can see that the RE share have gone up to 48%, and it has limited the, it's very clear that the coal have come down to 19%. Another interesting thing which comes into play here is the nuclear. The nuclear share have gone up from 5% from the stated policy scenario to here to 15%. It's because with the carbon tax in the market, costly nuclear have become a viable source of power. And also we can see that the hydro is contributing to 16%. The whole potential available in the hydro is being used here. With that, we are able to bring down the emissions from 1,800 to 750 million tons of CO2. Still, it is a little more higher than what it should be based on the Paris goal. So the last one which we are going to see is that putting a cap on the emissions from the power sector. What if you put a cap that the power sector cannot emit more than this, 562 million tons of CO2 in the year 2040? Let's see the results, what happens with that. So comparing all the scenario, what we see here is that the coal has come down to 14%. And again, what we see here is nuclear is becoming a power source which is meeting our baseload demand, reaching to 21% of the total energy mix. The total RE is being blocked at, it has actually decreased from what the carbon price was doing to 46%. Some slides are missing. Okay. So to conclude, what we saw here was that it's somehow missing there. Yeah, it's fine. With on the stated policy scenario, what the government envisaged, 36% RE share, we see that the emissions are still growing. And without a policy or RE target from the government side, we see that the growth is only 21%. And it can be seen that it is much more detrimental for the environment. And with the introduction of carbon price, we are able to increase the share of renewable energy and reduce the carbon, the generation from coal. And a newcomer which we see here is nuclear power. And once we put a cap on the emissions, we see that there's a further decrease. That's very obvious. And what we see here is nuclear is coming as a main power source which is powering the Indian power system. I think I finished much earlier than time. Thank you.